mysterious object collides with the black hole and it leaves astronomers puzzled because this shouldn't have happened. The black hole should have swallowed it. August 14, 2019, a gravitational wave, a massive ripple through the fabric of space-time, washed over our Earth, and the wave was detected by sophisticated fine-tuned lasers in the US and Italy. It was astonishing. While the lasers had previously picked up black hole collisions and neutron star collisions, they were now suggesting something unprecedented, that a black hole smashed into a neutron star. The signal was one of the strongest ever seen by the gravitational wave scientists at the Lazar Interferometer Gravitational Wave Observatory in Italy's Virgo Observatory, and after an alert was sent out moments after the detection, teams of astronomers across the world turned their telescopes to the point in space that the wave emanated from, but their searches came up empty. No light, no X-rays, no infrared, no gamma rays. The event was puzzling, and it became more puzzling as scientists began to pore over the data. The researchers from LIGO, and Virgo laboratories collaborations detail their full analysis of the gravitational wave detection. It was dubbed GW190814 in the Astrophysical Journal Letters, and it's the first detailed study of an epic cosmic collision, and it would only deepen the mystery. Roy Smith, astrophysicist at Monash University, Australia, says GW190814 is, I think, the first time we've observed gravitational waves where the source of the wave is genuinely puzzling. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. He said, I've been in LIGO for just over 10 years now, and this is certainly one of the most exciting events we've seen. The key to the research are the 2 LIGO facilities and the Virgo facility, which can detect gravitational waves. Extreme astronomical objects like black holes and neutron stars send out waves across the cosmos when they collide. And the facilities are essentially listening in to the sounds of massive cosmic beasts colliding with each other, and then working backwards to understand their physical characteristics. Smith and his colleagues have been working on simulating these types of collisions using supercomputers, which help perform that back calculation and can infer what the objects are, their likely masses, and their whereabouts. He said, we use fancy parallelized algorithms which can run our analysis on a supercomputer cluster containing many hundreds or thousands of individual computers. Running the same analysis on your laptop would have taken around 50 to 100 years. Can you imagine? Now, the observations show that GW190814, the pair collided around in a deep corner of space, 800 million light years away. One half of the pair is definitely a black hole, about 23 times more massive than our sun. But its dancing partner is mysterious. The other object is only around 2.6 times more massive than our sun, so that makes it about 1/10 of the black hole size, which puts it in a weird position. It could be a neutron star that possibly is still on the table, but it might also be another black hole, and that's a slight problem. Smith said it's hard to explain how either a black hole or a neutron star could be around 2.6 solar masses. Scientists have never detected a black hole that's so light. Neutron stars are not expected to be that heavy. They collapse back into the black holes, and then when they get too big. So the mysterious object seems to be some sort of Goldilocks star that does not fit our current understanding. Whatever it turns out to be, it will rewrite our knowledge on one of the 2 extreme objects. Intriguingly, if it's an ultra-heavy neutron star, Smith says, perhaps even new physics would be required to explain this. If it's a light black hole, then our understanding of how and where the light-hungry cosmic beast form will be rewritten. It's a win-win scenario for science. GW190814 is only the second time a gravitational wave detection has found a significant discrepancy in the mass of the objects. A collision between two black holes detected April 12, 2019, and dubbed GW190412, showed a mass difference of over 20 solar masses, and these great differences are incredibly helpful. They allow researchers to test Einstein's theory of general relativity. Both GW190814 and GW190412 fit with Einstein's predictions, so we have not broken physics yet. GW190814 is exceptionally rare. We've only seen one of these events in 3 years of observation, and it's going to be a while before we find some more. The LIGO and Virgo detectors have been shut down since March of last year, ending their observations run early due to the coronavirus pandemic, and they won't be back online until later this year. Our detectors are currently being upgraded, Smith said, so they will be more sensitive when they turn on again. And at that point, we expect to see not only more systems like GW190814, but probably other unexpected sources of gravitational waves as well. And that leaves a lot of room to try and explain the mysterious object. Is it a black hole? Is it a neutron star? They have no idea yet. So theorists have a lot of fun working ahead of them trying to explain GW190814, Smith said. This is by Jackson Ryan, CNET on Bended Reality. Please leave your comments. Thank you for your support.